In 1933, an inventor stood inside a laboratory and demonstrated something that should have changed the world overnight: a way to broadcast radio without static, in crystal clear high-fidelity sound. The biggest names in electronics called it a breakthrough. That was 1933. By the winter of 1954, he was dead, financially destroyed by the same corporation that had made billions from his earlier inventions. His body found on a third-floor balcony below his 13th-floor apartment in Manhattan. His name was Edwin Howard Armstrong, and 41 years before that night, he was a 22-year-old engineering student at Columbia University in New York City with a childhood fascination that bordered on obsession. He had grown up in Yonkers, survived a bout of rheumatic fever that left him with a permanent facial tic, and spent his teenage years building homemade radio antennas in his family's backyard after reading about Guglielmo Marconi's transatlantic wireless experiments. Under the mentorship of Professor Michael Pupin at Columbia, Armstrong channeled that obsession into something nobody had managed before. In 1912, while still a junior at Columbia, he discovered that feeding part of a vacuum tube's output signal back into its own input created a loop of amplification that could boost faint radio signals dramatically. He called it regeneration, and it was the first reliable method of amplifying radio signals ever devised. The regenerative circuit also doubled as a continuous wave transmitter, meaning a single device could both send and receive radio with unprecedented clarity. Columbia's engineering department watched a student solve a problem that had stumped professionals for years, and Armstrong received his patent for the invention in October of 1914. What comes next is the part that still doesn't quite make sense, because Armstrong was just getting started. When the United States entered World War I, Armstrong enlisted in the Army Signal Corps and shipped out to Paris, where he was tasked with intercepting faint high-frequency signals from enemy communications. The radio receivers available in that era struggled badly with high-frequency signals because amplifying and filtering them directly was nearly impossible with the vacuum tube technology of the time. Armstrong's solution was elegant and, as it turned out, permanent. He designed a circuit that mixed the incoming signal with a locally generated oscillation to produce a fixed intermediate frequency, which could then be amplified and filtered with far greater precision than the original high-frequency carrier ever could. He called it the superheterodyne receiver and filed the patent in December of 1918. Now, the historical record requires a brief but important note here. French engineer Lucien Lévy had filed a related patent roughly 7 months before Armstrong, and U.S. courts eventually awarded Lévy priority for the core concept on appeal. Armstrong built the first practical, working superheterodyne receiver and made it the global standard, but legal credit for the underlying idea ultimately went to someone else. This pattern of Armstrong being technically right but legally outmaneuvered would repeat itself with devastating consequences. The clock was already ticking on Armstrong's relationship with the radio industry. He just couldn't hear it yet. RCA, the Radio Corporation of America, saw the superheterodyne's commercial potential immediately and brought the first consumer superheterodyne radio, the Radiola AR-812, to market in March of 1924. The design proved so superior to every competing receiver architecture that it displaced them all within a single decade. And here is the detail that connects Armstrong's 1918 invention in a wartime Paris laboratory to the phone in your pocket right now. The superheterodyne principle, along with its modern descendants like zero-IF direct conversion receivers, remains the conceptual foundation of virtually every radio receiver, television tuner, cell phone, and Wi-Fi chip manufactured today. Engineers at institutions like EPFL and publications like IEEE confirm that the basic local oscillator and mixer architecture Armstrong designed during a world war still underpins the way the modern world receives wireless signals. One circuit architecture, designed in wartime over a century ago, still running inside billions of devices around the world. Up to this point, Armstrong had been winning on nearly every front. He was a decorated Army major, a Columbia University professor, the first ever recipient of the Institute of Radio Engineers Medal of Honor, and a holder of the French Legion of Honor. That was about to change completely. Armstrong's third and final great invention was wideband frequency modulation, known simply as FM. While AM radio encoded sound by varying the amplitude of a carrier wave, Armstrong's FM system varied the frequency instead, and the result was a broadcast signal almost completely free of the static and interference that plagued every AM transmission on Earth. He received his FM patents in December of 1933, and the man he chose to demonstrate this breakthrough to was David Sarnoff, the president of RCA and someone Armstrong had considered a friend for years. Sarnoff had even been involved when Armstrong married Marion McInnes, who had been Sarnoff's own secretary back in 1923. The personal and professional ties between them ran deep. Sarnoff allowed Armstrong to install FM testing equipment atop RCA's transmitter on the Empire State Building in Midtown Manhattan. And between 1934 and 1935, Armstrong conducted field tests that proved FM's superiority over AM broadcasting beyond any reasonable doubt. The audio quality was stunning, and the static was completely gone. The real question is, what happened behind closed doors at RCA after those field tests concluded? Sarnoff was not interested in replacing AM with FM. RCA had invested heavily in television development, and a successful FM broadcasting standard would have competed directly with television for both spectrum space and advertising dollars. RCA asked Armstrong to remove his equipment from the Empire State Building. Armstrong, completely undeterred, built his own FM radio station, W2XMN, on the Palisades in Alpine, New Jersey, and delivered the first public FM broadcast on July 18, 1939. The transmission tower he built at Alpine still stands today and houses a museum dedicated to his work. If Armstrong had stopped here, accepted a licensing deal, and walked away, this would be a very different story. Instead, what followed was one of the most destructive patent wars in American industrial history. RCA successfully lobbied the Federal Communications Commission, and on June 27, 1945, the FCC reassigned the FM broadcast band from its original range of 42 to 50 megahertz up to the 88 to 108 megahertz range still used today. The move rendered roughly 400,000 existing FM receivers obsolete overnight and forced every FM station in the country to rebuild from scratch. Armstrong charged publicly that the reallocation was designed to cripple FM broadcasting, and multiple historians have since supported that assessment. Armstrong had limited financial reserves to fight what was coming next, and the clock had already started. RCA and several other major electronics manufacturers stopped paying royalties on Armstrong's FM patents entirely. In July of 1948, Armstrong filed suit against RCA and NBC for patent infringement, launching what would become a deliberate war of attrition designed to bleed him dry. RCA's legal strategy was straightforward and ruthless, built entirely around delaying every proceeding, extending every filing deadline, deposing every possible witness, and requesting every possible continuance until the other side simply ran out of money. A friend of Armstrong later estimated that 90% of his waking hours in those final years were consumed by litigation against RCA. The financial toll was enormous. Armstrong's legal fees reportedly ran around $200,000 per year, and by 1952 he was borrowing money just to keep his lawyers working. In December of 1953, RCA offered a settlement of $200,000. Armstrong rejected the offer outright, viewing it as an insult given the enormous value his patents had generated for the entire broadcasting industry. The years of fighting had cost him more than money, though. His marriage to Marion had fractured after an altercation, and the couple separated. You would think someone inside RCA's leadership would have recognized what they were doing to the man whose inventions had built their company, but nobody ever stepped forward. Most people have never heard what happened next. Sometime during the night of January 31, 1954, Edwin Howard Armstrong put on his overcoat, removed the air conditioning unit from a window of his apartment on the 13th floor of River House at 435 East 52nd Street in Manhattan, and stepped out into the winter air. His body was found the next morning on a third-floor balcony below. He was 63 years old. He left a 2-page handwritten note addressed to Marion, and the New York Times reported that he was heartbroken at being unable to see her once again. When asked about Armstrong's death, David Sarnoff offered 5 words that have followed him through history. "I did not kill Armstrong." The story could have ended there with the inventor buried and his patents in limbo, but it didn't. Marion Armstrong spent the next 13 years doing what her husband no longer could. She pursued 21 patent infringement lawsuits, most of which Edwin himself had filed roughly 1 month before his death, and she won or settled every single one of them. RCA settled in late 1954 for approximately $1 million, roughly the same amount they had originally offered Armstrong back in 1940 before the relationship collapsed. By the time the final case, Armstrong versus Motorola, concluded in 1967, the total recovered was reportedly a little over $10 million. And the technology Armstrong gave the world did not merely survive his death, it won completely. According to the most recent Federal Communications Commission data, there are more than 11,000 FM radio stations broadcasting across the United States, dwarfing AM's total of roughly 4,000. Nielsen's most recent audio report found that radio still reaches 93% of all American adults every single month. The superheterodyne architecture Armstrong invented in Paris still hums quietly inside the receiver of every one of those stations, and inside every smartphone, laptop, and wireless router on the planet picking up a signal right now. Armstrong held 42 patents over his lifetime. He received the Franklin Medal, the Edison Medal, and the Medal for Merit from the United States government. He was inducted into the National Inventors Hall of Fame in 1980 and honored on a United States postage stamp in 1983. His laboratory at Columbia University's Philosophy Hall is a designated National Historic Landmark, and the transmission tower he raised in Alpine, New Jersey, still receives visitors who drive out just to stand where FM radio was born. The circuits outlasted the lawsuits, the corporation that tried to bury them, and the man who created them. What Edwin Howard Armstrong designed in university labs and wartime field stations didn't just endure. It became the invisible architecture of how the entire modern world communicates, and it has been humming uninterrupted for over 100 years.